Modulation modulation is defined as the process by which some characteristics of a carrier is varied in accordance with a modulating signal. A form of the carrier is sinusoidal wave. For the case of continuous wave modulation, the baseband signal is referred to as the modulating wave. So modulation is a process in which the characteristics of a carrier signal, carrier frequency, is varied in accordance with the baseband or information signal. So here we can see in this block diagram we have the modulator. This modulator is consists of some electronic circuitry which will do the processing on information signal, okay, and on the carrier signal there will be operation by the modulator so that this carrier signal will be modified or modulated, okay, into a desired form which carries the information signal. So out at the receiver end we need to extract the information from the modulated signal, okay, that that in order to extract the information signal from the channel output that is given to the receiver is known as the demodulation. At the demodulation output we will get the estimate of information or a baseband signal which is nothing but the transmitted information signal. The result of the modulation process is referred to as the modulated wave. Modulation is performed at the transmitting end of a communication system. At the receiving end of the system, baseband signal is to be restored. This is accomplished by using a process known as demodulation. What is actually demodulation? It is again demodulation. It is a circuitry, electronic circuitry, which will restore the information signal from the modulated signal. So why modulation is required? We can combine multiple signals, that is nothing but multiplexing of signals is possible with because of the modulation and practicality of antennas. See, for in order to transmit signal information signal for over a distance for long haul communication, okay, we need a large antennas, or the height of the antenna will be more. We cannot achieve that antenna height. So for that reason, if you go for modulation, you can reduce the height of antennas, which will be practical, which will be, you can consider practicality of antennas. We, without modulation, we need the antennas of length very large. Now we'll consider methods of modulation. So first one is analog modulation. Here both message signal and carrier signal are analog. And if I consider C of t as carrier signal and M of t as a baseband signal, so we'll have different types of analog modulation possible. One is amplitude modulation EM, second is frequency modulation FM, phase modulation PM. So all these are all analog modulation. That means both the message signal and carrier signals will be continuous or analog. Next is pulse modulation. The modulation signal is analog, but the carrier is train of pulses. The carrier signal that carries the information signal is a train of pulses. So that modulation is known as pulse modulation. Example will be pulse amplitude modulation known as a PAM, pulse amplitude modulation PAM, pulse width modulation PWM, pulse position modulation PPM. So these are the main categories of pulse modulation. Next is a digital to analog modulation. The modulating signal is a digital, but the carrier is analog. The information signal is a digital one, that is zeros, one, or pulses of try. Then but and the carrier is analog. So example will be ASK, amplitude shift keying; FSK, frequency shift keying; PSK, phase shift keying. See, these are all the digital to analog modulation. Information signal will be digital, and the carrier which carries this information is a analog. Okay. Next, fourth one is digital modulation. So here both information signal and carrier signal will be the digital. We have the example pulse code modulation, PCM, delta modulation, adaptive delta modulation. Okay, that completes this types of modulation.